Hello my goblins and ghouls, my name is Steven. Over the past few weeks, Lucian and I have been spending almost all of our time working on getting kits packed and ready to go out the door. After we sold out of all the units that we had already made in stock, a whole bunch more orders came in, and right now we're trying to make all the kits to fulfill the orders that have been coming in over the past few weeks. The first time that we made all these kits, the first batch that we made before we put out the launch video, there were a lot of things that we realized we could be doing a ton better. Lots of tasks that we realized took a lot longer than we expected them to, and things that we realized that there was a way to automate. This time we're buying and building machines that help us with that process. These are the kind of things that really make mid-scale workable. Instead of having to do all of these little tasks by hand, or instead of hiring a factory to do it for us, we can employ a couple machines and jigs that make the process way easier to do ourselves. So today I'm going to show you some of these machines and jigs that we made that have made the whole process of making a kit so much easier. All right, the first machine is for winding GT2 timing belt. Let's go take a look at it.
Cool, so in the LumenPnP kit, we actually have to include GT2 timing belt. So that means we make these bagged up sections of the belt. Winding it up by hand was really frustrating. We thought it took a good couple minutes to do it per bag, and who has time for that? So we created a 3D printed jig that actually winds up the cable for us. You just push it right into here. You pull it through to get all the twists out. And then what's really cool about it is that you can lock it into these little wheels. And now we can just start winding it up. Put a piece of wood there. We'll pop it out of the guide track. We'll wind it up that last little bit. And then we'll actuate the cam lifter. And now the belt spools are off. And then we'll just pick up our belt, wind it up, and put it in the bag. And you're off to the races.
So when we first did this, it took us like, I don't know, 3 or 4 minutes to manually wind it up by hand. How would you do it?
Dude, I would just be sitting here winding it like this.
That's dreadful.
This is awful. This took me about 5 hours to design, probably 3 hours to fabricate, discounting print time. It was faster to make this jig and use it in production than it would have been to actually do it all wound by hand, or even winding it all by hand with the assistance of a drill.
Yeah, time-wise, it paid for itself in the first batch of kits.
Yeah, that's the belt jig. So currently we laser cut foam for the packaging, and that's been really great because it lets us be flexible of our designs. But what it's been bad for has been cycle time. So it's pretty slow and tedious to use the laser cutter to do this. Cycle time's as long as 5 minutes to do certain sheets with a lot more features than this one. And it's just not stellar. So we're actually interested in switching to die cutting. Die cutting can basically be like a block of wood with what's called rules, which are sharp pieces of steel in the shape of your features. And that is then pressed into the foam with a pneumatic or hydraulic press, and it creates the foam cutouts you need. It can also be like a rotary action. Tooling is radially added to the die, and it would roll across the foam, and it would just let you feed the foam one after the other, and it just cuts through them all. We're not really sure which one we'll go with ultimately. Either way, we're gonna be coming up ahead by switching away from laser cutting. So something that ended up being pretty important was gluing some of the foam sheets together. This is foam sheet 2 and 3, and we had to glue them together because there's a staging plate cut out right in the foam. And we didn't want the staging plate to be able to slip through the 2 pieces of foam and be right up against cardboard. We wanted to make sure it's insulated in the packaging material. So that meant we had to put glue on this assembly, and then we also had to align them together after they've been glued. That ended up being a little bit more difficult than we would have expected. So we needed to make a jig or a series of jigs that aligns the foam for both spray glue application and as well as aligns the foam sheets together. That led us to creating these 2 jigs. We take a sheet of foam and we put it in here. We're set up pretty good to spray it. That then allows us to take this stencil with locating features in the corners and drop it on. Now we can spray glue, and the stencil keeps us from putting glue in regions of the foam where components will sit on that top surface. We have another one here that sprays the back side of the sheet that goes underneath it. And then we just take our stencil and we put it on. A little extra for good luck. And now we can lift our stencils. We need to align these 2 sheets of foam together. Then we'll take these 3D printed parts that pop into the 3D printed alignment features. Then what we can do is we lift out foam sheet 2, bring it in home. We lift it out from a corner. We have a glued assembly of foam. One thing I learned was that these stencils get nasty. We're also thinking about the idea of water jetting or laser cutting these out of an aluminum or steel so that we could just soak them in a solvent tank every now and then to get them real clean. I think it's a win. So when we were preparing the GT2 timing belt, we had to make sure it was all cut to the right length. What you could do is put a 5-meter tape measure on the ground and run out 5 meters and cut at the end of the tape measure, but that's kind of silly. So needless to say, we thought we could do a little bit better. And our first pass at that ended up being making this jig. We built it out of scrap wood we found in the office and a random 3D print we found on Thingiverse. Put GT2 belt on like a pivot point and we pull it through. And we have a bunch of pulleys in it. And what we do is just wrap it around until the belt has reached the requisite length. Now we know the belt is marked at 4.75 meters. Hold the belt taut here. And there you go. But we thought we could do better. So after some Google searching, we found that you could get a robot that cuts material automatically to the correct length for $300 to $500. And we thought we had to try it. So enter our microcomputer cutting machine. And it even has a fun button. So the way this machine works is that there's your spool of material that you want to cut. There's a guide track that you set to the width of your material. And it pulls it in towards a cutting blade with 2 urethane rubber wheels. After the wheels pull it in, it puts it past a set of blades that actuate just like this. Don't put your fingers there. We enter the length. We'll tell it how many we want it to make, and we'll say 5. And then all we need to do next is hit the start button. So we hold it for 3 seconds, and then it should just start. This makes all of the material for us automatically. We don't have to stand there and use a manually controlled jig.
Best $300 purchase. Are these ones that you've already done?
Yeah, so it made 75 pieces of this tubing in like 10 minutes.
What? How long would that have taken us if we didn't have this machine, even with the jig that you made?
Probably 60 minutes.
Wow. And also that time that it was running, it was completely unattended.
Yeah, fully.
Welcome to the team, buddy.
Yeah.
These machines have done so much for letting us get kitting done faster, and that lets us spend more time focusing on things like feeders and machine improvements and a whole bunch of other fun stuff we have in the works. And of course, this is just our first or second pass at some of these things. We're gonna find so many more optimizations as time goes on, and I'm really excited to figure those out and make things even smoother. For example, we just happened to find that machine that cuts belt and tubing and stuff. We just found it online and pulled the trigger on it, and it's done so much for us. If any of y'all know of any machines like that that could be useful for little processes, please drop a link in the comments. I'd love to see all the little tools and machines that y'all might have found that help with these kind of tasks. For example, we're thinking about maybe getting one that automatically winds tubing and cabling, and it looks really cool and it's so fast. That would save us a ton of time. So that might be one we pull the trigger on, but we'll see. Speaking of which, we've hired some folks. Opulo is now 4 people. Of course, Lucian and myself are the first 2, but we've also hired on a manufacturing tech to help us actually put kits together and someone to help us with customer support and documentation. We're working on getting them up to speed right now, but you'll get to meet them in the near future. Hiring and interviewing and that whole process was really interesting and difficult and kind of fun too. I might talk about that a little bit more in a later video because that has become a very huge part of what I do at Opulo now, and I was kind of not expecting it to take as much time as it did. And another bit of news, I've decided to switch to posting videos once every 3 weeks instead of every 2. More and more of my time is being absorbed by running this company, and this is what I need to do to continue to help it grow. I'll still be posting after shows on my Patreon the week after I post a video, no change there. And this also might free up some time for me to actually be posting some stuff on an official Opulo YouTube channel, which will be about documentation and getting up to speed and how to use your machine and stuff like that. This channel will still be about machine research and development and what it's like to try and get a hardware company off the ground. All right, that's it for this one. Thank you so much for watching, and I'll see you next time. God, I'm so fuzzy. I need to shave. Your boy needs a trim.